This is chapter 6, Motion and Time, class 7, and solution of this chapter. Fill in the blanks. An object is said to be at rest if it does not change its position with time. The SI unit of time is second. A child sitting in a revolving giant wheel is an example of circular motion. A car moving on a busy straight road is an example of non-uniform motion, though it can be rectilinear or linear motion as well. The speedometer of a motorbike measures its speed in kilometer per hour. Second is true and false. First is the speed of a fast moving train is usually measured in meter per second. This is false statement. Our average speed remains constant for an object having a uniform motion. This is true statement. A man walks for 1 minute at a speed of 1 meter per second along a straight track. The total distance covered by him is 1 meter. This is false. An object moving along a straight line is said to be in uniform motion if it covers regularly increasing distances in equal intervals of time. This is false statement. The time period of a simple pendulum that takes 42 seconds to complete 20 oscillations equals 2.1 seconds. This is true statement. The distance time graph for a car kept parked on a side road is a straight line parallel to the time axis. This is true statement. So correct the right option. Out of the following, only the correct formula of distance is distance equal to speed into time. Second is a man walks on a straight road from his home to a market 3 km away with a speed of 6 km per hour. The time taken by the man to go from his home to market equals to 30 minutes when you will solve it. The odometer of a car reads 57,321 km when the clock shows the time as 8:30 am. The odometer reading changes to 57,336 km at time 8:50 am. So time is this minus this. The distance moved by the car in these 20 minutes equals to 15 km. So this is 15 km. So this is solved. This is reading 1, this is reading 1, and this is reading 2, reading 1, and this is reading 2, and this is 15 km. Simple minus. Question number 4. Out of the following distance time graph, the graph that represents a truck at rest is the graph labeled at this one. See, this is time is increasing, but the distance is at the same place. This distance is not increasing. Here in this question number 5, in the given diagram of a simple pendulum, this is simple pendulum, the time taken by the bob to move from X to Z, it means this one is T1, this distance is T1, and from Z to O, and this is T2, this is from this to this is T2. The time period of this simple pendulum is, so this will be the correct answer. 4 times it will move from here to here, then here to here, again here to here. All this is T2, T1. So how much? Again it will move from this direction. It will go one round this side and again to this side. So it is, answer will be this. Question number 6. The SI unit of speed is meter per second. Now let's move to the D part. Answer the following questions in brief. A boy walks to his school with a constant speed of 4 km per hour and reaches there in 30 minutes. Find the distance of the school from his house. So speed of the boy is 4 km. This is 4 km. And time taken to cover the distance is 30 minutes as it is given. And 30 minutes equal to 1.5 hour. You can write it in decimal form in this way. We know that distance equal to speed into time. Just we have studied. So this is 4 km per hour into 1.5 hour. So r cancelled, and this is 2 km per hour. So hence distance of school from his house is 2 km. So question number 2. The distance between two stations is 216 km. A bus takes 4 hours to cover this distance. Calculate the average speed of the bus in km per hour. So it is given the distance between two stations 216 km. Time taken to cover this distance 4 hours, and we know that speed is distance by time. So equal to 216 by 4 hours, and this comes to 54 km per hour. Now two cars A and B starting at the same time from same point are moving with average speed of 40 km and 50 km. These are two different speeds respectively in the same direction. Find how far will car B be from car A after 3 hours. So speed of a car is 40 km per hour, speed of the car is 50 km hour. Time for both the cars 3 hours. We know that distance equal to speed by time, and distance covered by car A, this one, after this 40 into 3 hours, this is, here should be 40 km per hour. It should be written right. Always mention unit, and R will be cancelled out. Here also 50 km per hour, it has to be mentioned. So 50 km per hour, and this comes to this. So difference between car A and car B is 150 km minus 120 km equal to 30 km. So the car B is 30 km ahead or far from car A. Now question number 4, a car moves with the speed of 40 km for 15 minutes and then speed with 60 km per hour for the next 15 minutes. Here two different speeds. Find the total distance covered by the car in these 30 minutes. So distance covered in first 15 minutes 40 km per hour, and 15 minutes is equal to 1.5 hours. So this comes to 10 km. Again here in the next 15 minutes 60 km per hour into 15 minutes, and 15 minutes is 1/4 hour. So this comes to 15 kilometers. Therefore total distance covered is 10 km in the first case, first 15 minutes. In the second case, since the speed is increased, so distance covered is increased. So this comes to 25 km. Now define the term periodic motion. Give two examples of periodic motion that can be used to measure time. Periodic motion is a motion which repeats itself after regular intervals of time. It's called periodic motion. So example is motion of pendulum, motion of moon around the sun. And distinguish between uniform and non-uniform motion. Give one example of each. So this is when it is distinguished or differentiate, it is suggested that you write in the tabular form so that you can remember it easily, and it is easy to write as well. So uniform motion, an object is said to be in uniform motion when it moves along a straight path and covers equal distance in equal intervals of time. This is motion of vehicle moving at a constant speed. Whereas non-uniform motion is when an object moving along a straight path covers unequal distances in equal intervals of time, or does not move along a straight path. It moves its motion, it is called a non-uniform motion. So motion of vehicle on a heavy traffic peak hours can be considered as non-uniform motion. Question number 7, draw the shape of a distance time graph for a man waiting for a bus standing at one point on a bus stand. So this is the diagram. The distance is not increasing, but the time is increasing. Distance is not increasing, the time is increasing. So a man is just waiting. He's not in the motion. B, a man walking on a level, straight and narrow road with a constant speed. This is the diagram of this is the graph of object when it is in uniform motion, constant speed. So this is question number 1, the E part. Answer the following question. A farmer moves along a boundary of a rectangular field as shown in figure. He takes 4 minutes to travel across each side. It means the distance is this distance and this distance is different, but time travel is the same, time taken is same. So is the motion of this farmer uniform or non-uniform? It will be non-uniform because this distance and this distance are different, but the time taken is same. Find his average speed over one complete round of the field. So this is the answer. Motion of the farmer is non-uniform as it has not covered equal distance in equal interval of time. Average, so next part, average speed is, we have to find out the speed. So speed is distance covered by time taken, 240 meter, and time taken is 16 minutes. This comes to we will find it in meter per second. So 240 meter by 960 seconds. Change minute into second. So this comes to 1/4 meter per second. It means his speed is 0.25 meter per second. Second question, during rainy season, Shivam noted that the thundering sound of cloud was heard 6 seconds after the lightning was seen by him. If speed of sound in air is 340 meter per second, find the distance to the point where the thundering sound was produced. Given speed of sound 340 meter per second and time taken is 6 seconds, therefore distance is 340 meter per second into 6 seconds. Distance equal to speed and speed multiplied time. So this comes to this, and it when we change meter into kilometer, it is 2.04 kilometer, and thundering sound was produced at 2.04 kilometer from Shivam. Now let's move to the next question. This is, how can we make a simple pendulum? A simple pendulum takes this is numerical 10 seconds to complete 5 oscillations. Find the time period of this pendulum. A simple pendulum can be made by a metal ball attached to a string or thread that is fixed rigidly at one point. So number of complete oscillation is 5 as given here, and total time taken 10 seconds it is given. Now time period of pendulum is total time taken and number of oscillations. So total time taken is 10 seconds. We should write here, it should be 10 seconds and how many oscillations? Number of oscillations 5 oscillation. 5 oscillations equal to, this is 2 seconds per oscillation, right? We can say the time period of this pendulum is 2 seconds. Now question number 4, carefully examine the data given below for motion of two different objects A and B. State whether the motion of these two objects is uniform or non-uniform. So total distance, this is the graph that has to be observed, like 7 a.m. the distance is 0, 7:30. It means after half an hour 20 meters, and after 15 minutes it is 10:30. So this is the way the distance is covered. So let's move to the answer. So object A is in uniform motion as it covers equal distance and equal interval of time. You can see here, this is half an hour, it covers 10, 20, this is 20 meter, and again 15 minutes, 10 minutes, 10 meter more, again 15 minutes, 10 meter, again 15 minutes, 10 meter, again 15 minutes, this is 10 meters. So this is in uniform motion, but here you can see the distance cover is different, so this is non-uniform motion. Now here question number 5, observe the graph given here. From the graph find the first one, the value of distance P and Q. This is P and this is Q in meter. It has to be measured in meter. And second, the value of time R in seconds. Here it has to be in seconds. So here distance time graph is given and time is given in second and distance is given in meter. So it becomes easy. At 4 seconds it covers 3 meter. At again at 4 seconds it covers again 3 meters more, again 3, again 3, again 3, and here it is the time interval of 4 seconds. So let's see how it is been done. So value of P is 3 meter and Q is 12 meter and value of R is 12 seconds. Here you can see R. So here R is 9. So this is 12 seconds. Here this is 12 seconds. Now this is value based question in science class. Drishti observed a video showing the working of a pendulum wall clock. She noted that a slight change in the initial displacement of the bob did not affect the time period of the pendulum. When she had discussed her observation with her grandfather, he told her that we must also not let the effects of small disturbances to change the daily routine and the value of our life. So 4 values that should be maintained in life is courage, tolerance. So you can choose any 4. There are so many values that we should imbibe, and by this we can take any 4 out of these. And again the third is the small difference doesn't make any difference to the time period of the pendulum. So you can see That's all. This can be, this part can be, this is the second question. Design the activity show that a slight change in initial displacement of the bob does not affect the time period of the simple pendulum. This activity 3 from the book can be taken here. That's all. Thank you. Thank you.